Here is a larger neural network consisting of single neurons that all operate basically like the single neuron perceptron model that we're now familiar with. The only thing is that the activation functions might differ, and these neurons will have different numbers of weights depending on what dimension of inputs they're receiving. However, each neuron will still have only a single bias term. The non-final layers of a neural network are referred to as hidden layers. The final layer of the neural network is known as an output layer. Neural networks can have as many hidden layers as desired, but they always have one output layer. Sometimes you'll also see the input data being referred to as the input layer. But what they're calling the input layer are not perceptron-like units making computations. The input layer is equivalent to what I've been referring to as the data inputs. A fully connected neural network would compute information as follows. There is an input data of any dimensionality. So remember, we've talked about having face, color, and mouth angle, that's 2 dimensions. But if we had an 8x8 image, that would be 64 dimensions. This input, with this fixed dimensionality, is received by all the neurons in the first hidden layer. Every single one of these neurons in the first hidden layer is going to compute its own unique weights for every dimension of x. So for however many dimensions there are of x, each neuron has to find a weight for each dimension of x. Every neuron also has to have a single unique bias term, so it will also learn one bias term per neuron. Each single neuron is then going to compute its weighted sum of inputs, add its unique bias term, and feed this through its activation function to produce an output that gets fed to all the neurons of its subsequent layer that it's connected to. And here I'm showing a fully connected neural network, which means all the neurons of the previous layer are connected and feeding input into all the neurons of the subsequent layer. This is often not the case for many real deep neural networks. Often, neurons are only connected to some of the neurons in the subsequent layer, and neurons can also be connected to other neurons in its own layer. But for learning purposes, we're going to look at a fully connected feed-forward network. Every neuron in a fully connected feed-forward network is connected to every neuron in the next layer. This means the outputs from every neuron in the first hidden layer becomes the input for the neurons in the next layer. Now each neuron in the next layer has to find its own weights for each of its inputs. For the second layer, the inputs to this neuron are its inputs from its first layer neurons. So however many neurons it's connected to in the first layer, this is the dimension of inputs to the neuron in the second layer. Also, each neuron needs to find a unique bias term. Each neuron of this next layer then calculates its own unique weighted sum and then adds a unique bias and produces an output by feeding its weighted sum plus bias through an activation function. This neural network shown has only 2 hidden layers, but with more hidden layers, the process would just repeat itself over and over again. The outputs from the neurons in the output layer of the network form the ultimate outputs produced by the neural network model. Often the output layer will have different activation functions than the hidden layers so that it can produce the final form of the output that we want. As I mentioned, I'm showing a fully connected neural network, and in practice there are so many different types of connection patterns that neural networks can have. Neurons may be only partially connected to the neurons in the next layer, and sometimes for recurrent neural networks, neurons could be connected to other neurons in its own layer. However, the basic principles always apply. Every single neuron just does its own single neuron work. This is the end of our 3rd module, where we went over the power of combining single neuron models into multi-neuron networks. In the next module, we'll be discussing the very important problem of how neural networks learn.